Hello, everyone. Thank you for joining us today. We will be introducing James Picknell, who is the principal consultant at Conscious Asset. He will be giving some insight on how to know if your reliability and maintenance program needs any help. James, I leave it with you. Here we go.
All right.
All right.
Well, thank you very much for that nice introduction. One challenge that many of us have in our jobs is to really know when we actually need to get some help. In maintenance, we often have a pretty good idea that we're in trouble, but not always. And more so, our operational counterparts, general managers, and others quite often aren't really quite sure. They don't usually come from a background in maintenance or reliability, and consequently, they're not quite sure what to look for. So this presentation will hopefully give a few ideas on the sort of things that we can look for and maybe not find or find and tell us everything's fine. So just a little bit about my background. I am the principal consultant of Conscious Asset is the business name that we use. My background is entirely engineering, maintenance, reliability. I've been working in the field for well over 40 years now in various roles from ship's engineer to chemical plant maintenance engineer, reliability engineer, project engineer, and on into consulting, where I've been in a number of different companies and industries and worked on, I think, every continent except Antarctica so far. I've written a few books. Probably the best known is Uptime: Strategies for Excellence in Maintenance Management. The second and third editions I wrote. The first edition by my deceased colleague, John Campbell. I also wrote another one recently with Jesus Sofonte called Reliability Centered Maintenance Re-Engineered. So let's get into the reliability and maintenance program and determining whether or not we're in trouble with it. Now, reliability, of course, comes from really two things: having a design that is inherently reliable, and then from having a maintenance program that sustains that reliability. All right, we do need to operate the assets as intended, or at least within their limits, or we will also create problems that perhaps haven't even been considered in the design, especially if we overload it by too much. So how can we quickly determine if the program we have is capable of delivering high performance from the physical assets? So when I talk about the program, I'm referring to our proactive maintenance program, the preventive, predictive, and what I call detective or testing maintenance activities that we perform to really minimize or avoid the consequences of failures, noting that we don't always avoid the failures, but we can sure minimize the impacts on our business. Now, if you're not sure about how well you're doing, you could get a professional assessment. Call in someone like me or others who can come in and spend some time going through your operation, having a good look at things, providing you with both answers to whether or not you're doing well and how well, as well as giving you ideas about the situation. But that's a fairly expensive first step if you're not really sure of yourself. So this session here will give you some few key areas to investigate, which you can do on your own to determine if making that investment assessment is even worth your while. So here we're going to look at the health of the reliability and maintenance program. Now, we're all quite capable of keeping our assets running. We all do it to one degree or another. But a good reliability and maintenance program will achieve high output or high levels of production at lower costs per unit of output. When it comes to maintenance, I don't like to think of cost as being a big factor, but I do look at cost per unit of output and where that's been trending over time. Now, for any of these metrics that I've got below, the ones that are highlighted in red are kind of quick and easy ones to find usually. The red flag comment at the top is that any or all of these metrics can be challenging to find in some organizations. It depends a lot on how well you're actually collecting reliability inputs in your maintenance management system. And I do make a distinction between reliability inputs and maintenance data because maintenance data is often on its own just not enough. So there's three categories of indicators: asset indicators, reliability and maintenance program indicators, and costs. On the asset indicators, the big one for me is always availability. Do I actually have the asset available to use? Am I using it? Utilization. And what is the trend in its rate of failing? So is it getting worse over time or is it improving? For someone in operations, that a big red flag to them would be that you've got an overall frequency of downtime incidents that is higher than they can tolerate. Now, they often have somewhat unrealistic expectations. They may expect it to never break. So you do have to manage that. But they may, in fact, have a pretty good idea of what is acceptable based on their experience from elsewhere. Then we look at the reliability and maintenance program metrics themselves. So the proportions relative to each other of preventive and predictive and detective maintenance. We should look at how those maintenance tactics were actually determined. You know, do you just follow manufacturer recommendations, or have you actually gone through a rigorous analysis to determine them? And then we look at how much of the work is actually fully planned. Schedule compliance to me is a big indicator because if you can comply to a schedule, first time through especially, you actually have good planning, good scheduling, and a effective reliability program or proactive maintenance program that is indeed reducing the numbers of interruptions to the schedule that arise when failures occur. Now, when I look at cost and output, cost itself doesn't tell me much at all. That varies with the size and complexity of an operation. But the cost per unit produced, that can be a very good indicator and quite easily compared with others if you're able to get a hold of their information as well. What you want to do is lower the cost per unit produced, not necessarily lower the costs alone. Now, when I look at asset performance, I'm going to go through each of those three categories a little bit here. Availability is one that is a good indicator of whether or not your overall program is working. The asset itself, if it's running, if it's in use, if it's idling, if it's on standby or shut down and ready to be started, then it is available. So just like your car in the parking lot, you may not be using it, but it is available for you to use. So that's availability. Now, there's a couple of different ways to measure it, actually more than a couple, but I'll do two simple ones here. Mechanical availability considers only the downtime incurred to do maintenance activities. So that would include shutting it down to do, say, an overhaul or a part replacement, or to do a repair. Operational availability, which is the one that bugs your operators, considers all the downtime. So that would the downtime there starts counting the moment that the equipment shuts off and doesn't really start counting again until they're putting it back into use. Changes to that one can show up fairly quickly if you're doing good with your reliability program. Another indicator is the utilization by the operators of the asset. It also can change quite quickly. Clearly, they cannot utilize it if it's not operational. And if it's available but failing often, they may also have a low utilization because of the disruption that creates to operations. Availability itself is a result of reliability. Now, it's often measured using mean time between failures, but I don't like to use that as an indicator of a program, certainly not over a short term, because changes to mean time between failures can take a long time to show up. If you think of a failure frequency that generates a mean time between failure of, say, 2 years, well, if you've made an improvement that even improves it up to 3 years, you're going to have to wait a few years before you actually see that change showing up. So it's not a good leading indicator at all. Now, the number of downtime incidents is something that you can monitor in pretty much real time. The operations folks will certainly feel this one, and they often measure it even if you don't. It can and likely will show up in the operational world as a failure frequency or number of incidents across the entire operation. So anything that takes production down is likely to get counted. Trends in that can be pretty indicative of overall reliability, and changes in that will indicate the effectiveness or lack of effectiveness of both your PM program and whether or not you're able to comply with schedules. Typically, if your PM program is not very well developed, very well defined, your PM schedules will be difficult to sustain because the PMs themselves are not actually eliminating the failures to the extent that they should. And that's an indicator to you that, hey, maybe we better look at that PM program. So our other indicators of performance are the actual reliability and maintenance program itself, how we measure what we're doing. All right. And high performance programs share some leading indicators that are pretty good to use. Now, if any of your metrics look a little bit too good to be true, they probably are, right? And this is an area where people get the measurement inputs often wrong, incomplete, inaccurate, and sometimes things are coded incorrectly. We mix up preventive and predictive. Many organizations consider predictive to be preventive. Well, it's not. They don't even think about detective in a lot of cases. If they've done something like reliability-centered maintenance, they will probably know what failure finding testing is, and that is detective maintenance. It's looking for flaws and equipment that's actually already failed, but hasn't been called upon to be used yet. So this is like finding your smoke detector not working before you have a fire, right? You're going to do something about it and avoid the consequence of the failure. Preventive is the sort of work that where you're changing things out. You're doing overhauls or part component replacements. And predictive is the use of condition monitoring, just like lube analysis is a very good example of that. You've got corrective maintenance. Should be non-urgent, planned and scheduled. Most of that should be the bulk of your work if you've done a good analysis and determined what you can allow to failure. Now, sometimes you will get failures that occur. They can be treated as urgent. If you know that they could happen, again, through that analytical process, you would actually have them planned in advance, but you wouldn't necessarily have them scheduled. You wait until they fail. And then, of course, there's the emergency stuff, which in most cases are failures that no one anticipated, even if they did a rigorous reliability-centered maintenance type of analysis. And these things can often have very serious consequences, so they get treated as emergencies. They break into existing schedules, break into existing jobs even. Other metrics are the amount of planned work, the amount of scheduled work that you're doing. Those both should be quite high. The compliance to your PM scheduled, and there's two ways to measure that. The most common one is based on this week's schedule. How much of that did we get done? But a little bit less common is measuring it on the basis of the first scheduled date. Right? Many organizations will find that If they can't get something done in 1 week, they'll move it to the next week, and then it'll show up as compliant in the following week. But it's actually non-compliant to its original schedule. So it's good to measure both of those to give you an idea of how much slippage you have in attaining your schedule. And then we look at how many of your asset tactics, how much of your PM program is defined using the various methods that are available, like reliability-centered maintenance, which in my books is the best method. You've got PM review and optimization, which looks at an existing program to optimize it. You've got root cause analysis or root cause failure analysis, depending on which flavor you use, which is a great reactive way to improve maintenance programs after failures have occurred. You've got manufacturer recommendations, which, in my opinion, are often not the best. They tend to be overly heavy on part replacements and overhauls. And of course, that's good for the manufacturer. And of course, then some have taken those and just modified those on the basis of their experience, which enhances them a little bit. On the cost side, I look at cost per unit of output. So whenever reliability increases, we typically see the cost of a maintenance program go down. And that's, of course, because you're doing more proactive work. Your preventive, predictive, and detective work is often much less cost. It's virtually always planned and scheduled, and you're able to get it done on schedule if you're under control. The predictive and the detective maintenance often do not consume materials at all, and the preventive, of course, will. But because you know it's coming, your supply of parts is usually quite reliable for that. So reliability increases do end up delivering higher levels of availability, which enables operation to utilize the asset much more. So what I look for with cost per unit of output is a trend downward in maintenance cost per unit. So that could be dollars per ounce, dollars per ton, dollars per unit produced, whatever, depending on what you actually produce. So is your program in trouble? Well, if you feel the performance is low, if you've just got this gut feel that we're not doing as well as we could, then you probably are in trouble. If you feel uncomfortable or uncertain, and you don't really have measures to look at, then I can tell you that you almost certainly need to get some help. The lack of measures speaks volumes about how well you're managing the whole activity. Achieving high levels of availability does take a lot of effort doing the right things the right way, and I'd add at the right time. Managing that requires measurement of what you're actually doing so that you can actually see results. Another way of knowing when you're in trouble is whether or not you're having a nice stable operation or whether the operation is in a state of chaos. And for that one, you can simply look around. You can see whether the operation is running stably or whether it is chaotic. If your maintainers are simply too busy to measure things, then you're also in trouble. A disorderly appearance, I've said to people, I can walk into many operations and within the first 20 seconds, you can tell whether they're in trouble or not. They often look like they're in trouble. You can see parts, materials, used materials just all over the place. The place is usually filthy. It looks hazardous, and it probably is. That chaotic look indicates that you've got a reliability and maintenance program that is in trouble. So look at the trends in your program results and the reliability metrics. Ask your operators and ask your financial managers what they think about your performance. Now, they may not know much about what you actually do, but they will see the results. And the operators, to them, it's disruptions, stability of operation. That's what they're looking for. For your financial managers, it's stability of revenue stream and whether or not costs are under control and being spent steadily. Right. So they often have pretty good indicators of their own that are not related directly to the equipment, not directly related to reliability, but they're very good indicators of whether you're doing things right. So that's, I understand I'm supposed to talk for all of about 20 minutes. I think I'm a minute early here by my clock. Are there any questions? And what I'll do is I'll stop sharing so that I can see what's going on the screen myself.
Thank you very much, James, for that wonderful session. We are open for some questions and answers. If anyone has any questions for James, I encourage them to please submit it in the chat box. Let's see if we get any questions for you, James.
It was either too good or too basic, maybe.
Too good, too good.
That's what I like to tell myself. These questions are easy to answer.
I also encourage everyone to connect with one another, connect with you, James. And if they don't want to, ask any questions now, maybe they could ask you questions privately.
Sure.
Yeah,
They
that'd
can
be
do
another
that
way.
here. Do they have my contact information there so they can contact me if outside of this event if they want to?
I believe so. I believe everyone can connect with you.
Okay.
Um, so, yeah.
I guess another question I would have for you is are the slides going to be shared afterwards with the
Yes,
attendees?
the whole recording will be shared. Um, it'll it won't be today, maybe a little bit later on. Yeah, but it will be available for everyone to restream.
Okay.
Hmm.
Terrific.
Let's give it a few more minutes.
Sure.
Yeah.
After this, it's off to lunch for me. So, do we know how many people are in the event itself?
No, I don't. I don't see. I don't see that.
Yeah, I
Sorry.
don't see anything on my screen either.
Mm-hmm. Yeah.
I think perhaps the actual event site where you can log in to watch that probably has some.
Right.
I've got that off right now, so I don't interfere with this.
Okay. Do you have anything additional to add, James?
Well, the only thing would be, I guess, assuming anybody's there listening, is I often, I mean, I do quite a few conferences, and I'm often asked for copies of my slides, and I'm quite happy to share that.
Okay.
Um, PDF format, or is typically how I would do that. If anybody's interested, I just invite them to let me know.
Great,
I'm not
great.
hard. I'm not hard to find, and they should have the contact details here. So
Great, great. Yeah, I encourage, like I said, I encourage everyone to connect with James. You could do that once you log in. You could automatically connect with him, ask him any private questions, and go from there. But if that's all, James, I'd like to thank you for a wonderful session, very informative, and hopefully we get to do this again next year.
sure. Well, thank you.
Thank you
And
very much, James.
good
All
day
right,
to
guys.
you and everyone.
Good day. Bye bye.
Bye for now.